congruence when we're talking about shapes, and we talk about what is required for two shapes to be congruent and how we can use that information to help us solve for things. So we have this one up on the board that says describe and correct the error in each example. We'll have another one in just a moment. But we were told that triangle FEH is congruent to triangle GDJ. So this student answered that I think H is congruent to D, so H has to be 38 degrees as well. Do you guys agree with this?
No.
Why not?
Well, I thought the reasoning's kind of dumb. It doesn't make sense. But like how we learned yesterday, like at the end is H, but at the end of the other one is not D. But I don't know how to put that into words.
So H, which one would H correspond to?
J.
J. So those should both correspond to those corresponding letters should fall apart or should correspond with each other. So H obviously should match with J, not with D. So that does not mean H is 38 degrees. If we were to try to fix this, which angle in this triangle would you say is 38 degrees?
E.
E, because E and D are both those middle letters. That means E and D should be the corresponding congruent angles. And so E is 38 degrees, and that's really just what you would need to do to be able to fix this. So if you were to correct this on something and actually put it into words, I would say this student is incorrect because H corresponds, or from our congruent statement, H corresponds with J, and D should correspond with E. Therefore, E should be 38 degrees. You could say something like that. If you were to correct. So let's look at another example like this. So we have this triangle, we have triangle ABC, and inside we have triangle DEC. This student answered either that they think that triangle ABC is congruent to DEC because the corresponding angles are congruent. Do you agree with their statement?
No.
What do you not agree with?
The city's not congruent to anything.
So triangle ABC and triangle DEC, they both have angle C, and so C would be congruent with itself, which is what we call the reflexive property. Yesterday we saw an example where triangles share two sides. We had that two triangles share the same side. So they both share that same side, so that side was congruent with itself. That's what's happening with angle C. They both share angle C, so C is still congruent with itself. But is it still enough to say that these two triangles are congruent to each other? Do you agree that ABC is congruent to DEC? What do we need in order for two triangles to be congruent? They need corresponding angles, but they also need corresponding sides. Are those sides the same line?
Yes. No.
Is AB the same length as DC? No, this is much shorter. And so is this one. This is much shorter than our full way out here. I'm just scribbling all over the board now. So in order for two triangles to be congruent, they need congruent angles, but they also need congruent sides. And so we might have congruent angles in this situation, but we don't have congruent sides. So these two triangles are not congruent. And so this is not enough information to say that these two triangles are congruent just because they have congruent side or congruent angles. This student would also say these triangles are not congruent because the side lengths are not the same length. So in order to show two triangles are congruent, we needed a lot of information. We have to know that all three of those sides are congruent to each other, and that all three of those angles also have corresponding congruent angles. Oh, I should be there. So we have to have a lot of information. We have to know all of that in order to be able to tell two triangles are congruent. We have to say each angle has a corresponding angle, each side has a corresponding side, and they're all congruent. That's a lot of pieces of information in order to show two triangles are congruent. And that's just our simplest shape. It gets even harder if we have a square. We have to show all those angles in those squares that are congruent. Or if we had a pentagon, or like a 5-sided shape, or a 9-sided shape. That's a lot of sides to match up, right? And this is just the triangle. This is our easiest one. We already have 6 things that we have to match up on both triangles. That's a lot. It's going to take a lot of work, right? So our goal today, because we're lazy, we want to see if there's shortcuts we can go for. Rather than having to figure out every 6 piece of information on both triangles to show that they're equal to each other, we want to see, is it possible if I can just figure out 3 pieces of information, is that enough for me to show that my 2 triangles are either A, congruent, or not congruent? And so we call these congruence triangle or triangle congruence criteria, or triangle congruence proof criteria. So when we're looking for these shortcuts to determine if it's enough information, so for example, if I know 2 sides are congruent on this triangle and 2 sides are congruent on this triangle, and then I know one of those angles are congruent on both triangles, is that enough information for me? If I know all 3 sides on this triangle and all 3 sides on this triangle, is that enough information? These are some things we're going to look at. These are some things we're going to try to figure out in the next 2 days. So we're going to take a little time focusing on it today, and then we're going to talk about it a little bit more tomorrow, and actually talk about what are these criteria and how can we use them. And so there's a link on this page. So pull out your Chromebook, pull up this link, and once you pull it up, we'll talk about when you get there. It'll probably take, it's going to take you to a website called the National Council of Teachers of Mathematics. If you scroll down a little bit, it should have a little large box that says Adobe Flash Player needed. So enable Adobe Flash Player if I click on the allow button, and it should pull up this big blue box. So put in that bit link, and it should take you to the website, enable Flash Player, and once you get there, we'll talk about what comes next. All right, so we should have this at the moment. So it says choose 3 elements to make a triangle, and then should have your sides and your angles and all that. Are we here at the moment? Are we okay with this? Right. So all of you should have received a piece of paper. So these pieces of paper are sort of split up into different sections. There's 6 total pieces, or 6 total parts or sections. And so at the top of them, it says something like side, 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 or side, angle, side. So basically what we're doing is we're looking for these shortcuts. So rather than being able to figure out all 6 parts of those original triangles, be able to show that they're congruent, we're seeing if I can create a shortcut just knowing 3 pieces. Some of these shortcuts might work, some of them won't work. That's what we're going to try to figure out today. So for example, one of those shortcuts is, if I have 3 congruent sides, is that enough to show that any triangle made with 3 of the same sides is always the same triangle? Or is it possible to make 2 different triangles using 3 congruent sides? That's one of the things we're going to try. And so what you would do is you would highlight those 3 sides, and then we need to build a triangle with these. So all your sides should have like a number or a letter at each side. You're going to need to connect those letters. So A is going to have to connect with A, and I can start forming a triangle. B is going to have to connect with B. So I'm going to move my triangle down here. So they should automatically connect together. Sometimes you have to finagle with it a little bit to get them to work together. So we need to connect these 2 sides to make my triangle. So I have C and C, I have to connect them together. And boom, I got a triangle.
How do you flip it?
You should just be able to grab, if you grab at the edges where the letter is, you should be able to draw them on the line. It should have to.
So I go like right here.
Yeah, and then you should. Okay. Now let's grab C.
Just the letter.
So we're going to move that, and then we're going to move A down here. And then you want to see if you can connect C, those 2 C's together. So we should get a first triangle from all. So once you get that first triangle, it's going to ask you to try to make a second triangle. So it's going to give you those exact same pieces you used on those first triangles. It's going to give you the exact same lengths of those sides, or the exact same angles you used on the first one. But we will need to do it again. So it's going to ask you to build it again. So using those pieces, I'm going to try to build that exact same triangle again. The thing is, your triangle might be rotated around, it might be spun around, that's okay. We just wanted to see if we can build it twice. And so I get a second triangle. If I were to spin it like this, I think it's flipped around. I should. I can't flip it. I do have the same triangle. These are congruent to each other. But you can sort of like line them up to be able to tell. And so, once you get two triangles that are congruent, it's going to ask you to try and make a third triangle. Now the thing is, some of these, it's impossible to make a third different triangle. Your third triangle is going to ask you to make one that's not congruent, one that's different. Some of these is impossible to figure out that is different. And so, rather than having you struggle through and try to make a different triangle that's impossible, on this piece of paper, it tells you which ones are possible and which ones are not. For example, side, 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 it says, explain why these are always congruent. I won't necessarily have you have to explain. If you have some thoughts on why you think they're always congruent, you can write it down, but you don't have to put anything in here if you don't want to. So for example, it is impossible to make a fourth or a third different triangle from these. It's anytime you have three sides that are the same, those will always give you congruent triangles. So for that other box where it says draw a sketch of the triangle, you're gonna then draw an example of two triangles that have three of the same side lengths that are congruent. So I have two triangles here with three congruent sides, so each of those sides match with another side. This is an example of, the only thing I know about these two triangles is that they have three congruent sides. I don't know anything about their angles, but I know that they will always be congruent.
What is the description part? Why are these always congruent?
Or explain why these are always congruent. Don't worry about that for now. We'll talk. That's the main thing we're going to focus on tomorrow. And so once you get that first one, you would then be able to move on to the second one. So side, side, angle. So for side, side, angle, we need two congruent sides and an angle. It should tell you at the top. So up here it says side, side, angle. So in case you're confused on what one you're doing, it should say up here. And so for this one, we would do pretty much the exact same thing. It's going to ask you to build a triangle. So you're going to build a triangle with those pieces. If I can do some. So when you connect that angle on there, you're going to have to put one side connected to that line segment. It's going to draw another line shooting off of it. So I'm going to put B on B. And now what I need to do is I need to get A on that line. So I'm going to move A. And I just built myself a triangle. And it's going to ask me that again. Build that same triangle again. Using those same pieces, do it again. So I'm going to put my pieces there. And I'm going to try to do this one more time. Oh, I have to move it down. So I just built my same triangle again. And once again, you can take them and you can sort of line them up, and you can see, oh, yeah, these two triangles are obviously congruent. They're obviously the same. So I can hit yes. And then once again, it's going to say, is it possible to use those three pieces to build a triangle that's not congruent? Is it possible to use those three pieces to build a triangle that looks different from these two? Once again, I could have you struggle, or I could have told you the answers right away. So this one, it is not possible, or it is possible, to make a different triangle. So it says it's not always congruent. So not always congruent means that there is another triangle I can make using these exact same pieces, using the exact same starting components. I'm going to try to make a different triangle. So once again, I'm going to try to line them up like I had. Now I'm going to see if I can, is it possible for me to connect to a different triangle? So all of our other triangles, they look something like this. We connected it up here and we got that triangle. But if I bring this down, and if I connect way down here, that's a triangle with exact same angle, exact same side lengths, but it's obviously different. And so this is a not congruent triangle. So for side-side angle, it is possible to use those exact same pieces and make two completely different triangles. And so what it's going to ask you is it's going to ask you to draw a counterexample. So your counterexample could be like this. These are two triangles that look the same or that have the same pieces, but are completely different. And that would be something you can put for a counterexample.
My two triangles, I got one that looks like that, but I didn't get one that looked the same as that.
Okay, so it's always going to ask you to try and make two congruent triangles first and then make a different one. And so when you're supposed to make a congruent triangle, you made a different one. But that's okay.
Okay.
But now you already know what the counterexamples look like. So that's fine. So once again, some of these, it's impossible to make a different triangle. Some of them, it's always going to make a perfect, all triangles are always going to be congruent. Those are our special shortcuts that we're going to remember for later. Some of them you won't be able, or some of them you will be able to make a different triangle. On the ones you will be able to make a different triangle, it's going to ask you to draw a counterexample. On the ones that won't be able to make a different triangle, it's just going to say draw a sketch of two congruent triangles with these situations. So for example, if I want to draw a sketch of side angle side, I would have two triangles that are congruent. They share two sides that are they share two angles that are the same, and then that side in between them needs to be the same as well. That's what I'm told for side angle side. So go through, work through these examples. If it's possible to make a different triangle, make a different triangle. If it's not possible to make a different triangle, stick with, or just make two triangles of the original, and then draw your sketch showing what pieces you need to know in order for them to be congruent. You hopefully should be able to finish by the end of the period. If not, that's okay. Make sure you hold on to this paper for next week. If you have, or not next week, tomorrow. If you have questions, just let me know, and I will walk around and help.